Hi, my name is Edith Beigne, and I'm going to talk today about augmented reality applications and all the circuit design challenges that have to be addressed to enable what we call the metaverse. I work at Meta, formerly known as Facebook, in Reality Labs, and I support a team of research scientists. My background is circuit design, analog, mixed signal, and digital circuit design with an expertise on low power design. In addition to being at Meta, I am the ISSC 2022 TPC chair. The last decade has really seen the revolution of the smartphone. Clearly, what we think is that the future of our personal devices is going to be more portable and more personal. We all have a smartphone in our pocket, and this smartphone is not necessarily extremely personal. We want to build something that is more related to who you are and to your context and to the person you're connected to. We're building devices to enable what we call the metaverse. So the metaverse is a set of interconnected digital spaces that lets you do things you can do in the physical world, and that's going to be enabled in part by augmented reality. It will be characterized by the sense of social presence that we don't necessarily have today with our connected devices, and the feeling that you're right there with another person, no matter where in the world that person happens to be. During the talk today, I will really share a look at what we are building to improve virtual and augmented reality as we know them today, and the steps we are taking to help realize the full social potential of the metaverse in the future. I'm going to highlight everything in terms of hardware that it's going to take to get there in the future. It's been predicted that instead of carrying smartphones as we do today, we will wear stylish glasses. So here in that slide, you can see AR glasses. AR stands for augmented reality. Those glasses, they will offer virtual reality, augmented reality, and everything in between. And we will wear them all day and use them in almost every aspect of our lives. The distinctions between augmented reality and virtual reality will vanish, and really the real and the virtual worlds will just mix and match all together throughout the way, according to our needs, according to our context, according to who we are connected to. So what do we imagine? I like that example where you can feel the presence of someone in your family that is far away. We've been all living, or some of us living far from our families and friends during the past 2 years, and we're missing that feeling of presence from them. So building the augmented reality in a way that you can get more connected with people in many important occasions, but also in a day-to-day basis, is something extremely important for the future. So we could enable many different things there behind. We could better see in low light. We could also see people and places on the other side of the world. We could experience many new experiences for better vision or a better understanding of our environment. I like that example of remote work and working with people at different places, and I think we've all been in that situation recently. And imagine that glasses that let you and your coworkers pop up a shared whiteboard in your office, wherever is your office. That notion of sharing information is extremely important, because the more you can share your context, the more you have the feeling that you are in the same room as another person. The idea is that you could also bring up your entire workplace wherever you are in a complete privacy setting. Look at that example on the right for that private workplace on an airplane. Obviously, privacy is extremely important in that situation, because you do not want to share your workplace context with everyone in the plane. So the future of augmented reality is going to be built on 3 pillars. The first one is about driving the perceptual system, then sensing and reconstructing the reality, and then interacting with others. those three pillars are really important to understand. First, driving the perceptual system. We all have experiences based on our personal filters, based on our expectations, interpretations, based on who we are, on where we are. And we construct actually a very personal view of the reality, which is our own reality. That's what we call the perceptual reality. So the idea is to be able to really drive that perceptual system with augmented reality and AR glasses. To get there, we need to build those two other pillars. First is sensing and reconstructing the reality. How can we make sure that we provide all the hardware and software to sense correctly everything around in the reality and then reconstruct it in the glasses to provide a better experience to the user? Interacting is important. You see here I'm using my hands a lot. We interact with many different ways, with eyes, with hands, with ears, and we really need to make sure that we can provide that interaction in the best possible way so that we enable all the experiences of augmented reality. An interesting example of interaction is this virtual keyboard that you can see here happening on the top of that slide. We are really putting everything together, all the different building blocks to make this happen and real, including the input systems, the display systems, and all the audio systems. So everything that is an input in terms of interaction to the AR device. We have teams of neuroscientists, engineers working all together on neural interfaces, for example, and way to use gestures to control augmented reality objects in the world. There are still a lot of very hard problems to solve, but this is the opportunity to open up a lot of new ways for people to connect, to work, to learn, to play. And we now have a line of sight into how we are going to get there in the coming years. Getting to our subject of interest for today about integrated circuits. Actually, in our devices and in augmented reality devices, silicon is everywhere. We have new displays and technologies that need completely new drivers and new integrated circuit for driving those. It's extremely challenging to get a display that is see-through and really providing all the experience we need for augmented reality. Audio is extremely important. We need 3D audio specialization, beamforming, new algorithms, and all of this needs a lot of advancement and a lot of acceleration from circuits to really provide the best possible audio experience to the user. I mentioned about interaction, and hand tracking is an extremely complex problem to solve. To get good enough to appeal to users, something that you even don't think about when you're using it as an input device. Everything related to interaction is not only for hand, but everything related to all the input device that we're going to build for AR is a big challenge to solve in circuits. Computer vision, you've seen the examples that I've shown before. Computer vision is a very complex problem. It has to be extremely high performance while being low power because you want to extend the battery life of your device as much as possible. But still, you need to really understand correctly, reconstruct the reality, being able to drive the perceptual system, that's what I mentioned earlier, goes a lot through the computer vision. Machine learning, artificial intelligence, this is also a lot about interacting with others, learning about the environment, learning about all the sensors we're going to have on those devices, really being able to provide an accurate information based on everything that all the sensors can provide to the device. User experience is actually really at the center of everything we're building. We are really looking at what would be the best user experience for AR glasses. We are really listening to feedback from users. We are really trying to make sure that we understand the needs. We also understand the limitations, and we build the devices for the user to get the best possible experience. That one is a very important one, system design. A lot of people, they do not necessarily have access to an entire system where they can look at where is the silicon and what is the best possible integrated circuit that can be designed. Here, it's a very complex system. We're building a complex system with sensors, displays, computation, inputs, outputs, a lot of hardware put all together to make the system work in the best possible way. So each time you're going to do an integrated circuit in that system, you really need to understand all the components of it. It's not about building one block, it's building a block in the knowledge of the entire system. And this is really something important to emphasize, because that is going to really give you the best possible ideas to innovate and to create new circuits for augmented reality. So what are all the challenges for augmented reality silicon? So first, you've seen the different devices I mentioned, and specifically AR glasses. Form factor is the first one. We need to really get everything smaller, more integrated, and that's going to require a lot of integrated circuit silicon. It's not only for compute chips, but it's also for sensors, for drivers, for all the circuits delivering the power to the chip. That is something extremely important. Form factor is really one of the major constraints. Second constraint is this balance between high performance and low power. We want to go really low power because we want the battery life to be extended as much as possible, but still we need to provide very high performance to the system so that you can compute a lot of information on the glasses without necessarily sharing information with any of your other devices. Power is, in addition, extremely important because of the thermal limitations. We want to limit, of course, the heat dissipated on the glasses around the skin, and that is all related to how much we can reduce power. Wireless, how do we connect all those devices together in the best possible way? Latency is important, privacy is important. You're going to share some data to other devices, and you want to make sure that the links are extremely reliable and the links are extremely high performance, so that you do not feel any kind of latency between the information you want to compute and the information that are displayed on your glasses. More compute, less latency. That's exactly what I mentioned before. You want to compute as much information as possible in the glasses, in the devices, to really provide the best experience to the user in terms of latency and compute. Graphics displays. There's a lot to do around rendering on the glasses, making sure that the display, the hardware display, is see-through, very high quality. That's going to be the first thing you're going to see when using the glasses, so that has to be super high quality. And there is a lot to do in silicon in there to make sure that we are driving the displays in the best possible way in terms of accuracy. So there are a lot of skills here that you're going to be able to experience with augmented reality. This is not exhaustive, of course, but I'm talking right now to students and young professionals working on circuit design. So I thought that would be interesting to show you what kind of skills are going to be required here. It's a set of all those. It could be one deep of those, but that's all of this is required. System level understanding, I have explained why you need a very good system level understanding of all those pieces together. Hardware and software co-optimization, we do hardware, but we also need to enable software in there. Machine learning, wireless, sensors, displays, compute and memories, everything that is related to security and cryptography is going to be extremely important because that's our top priority. And new technologies, maybe you work more on the device side of things, and that's all good because we also need to innovate at all levels in the glasses. A lot of curiosity, obviously. Everything is really new, so we want people who really want to innovate, who are really looking at all the different parts of the different devices and how we can optimize all of those. You see here in those glasses all the different pieces that have to be put together. This is a research prototype here, but that gives you an idea of everything that has to be addressed to make it work. So this is ending my talk. Thanks a lot for listening.